to the Biomass and Biofuel Development Panel presentation. I'm Stephen Webster. I'm president of MW Consulting. We're up in Tallahassee. As I must have been evil and lazy in a past life, I am a lobbyist in this one. That means that we try to follow the machinations primarily up in Tallahassee in the legislature regarding fuel, biofuel, bioenergy, and agriculture and marine work is primarily categories that we follow. We lobby on behalf of feedstock farmers and biodiesel producers, biofuel generally, but biodiesel most in particular. And in fact, what little energy legislation there is in Florida, a few years ago, we helped write a good bit of it. And yeah, I'd love to talk with any of you about how we can help with government issues in the future. In a moment, I'm going to introduce our panelists and ask them to introduce themselves actually a bit. But before I start, I want to talk about the panel's objectives and how I'll moderate what we're doing today. In my opinion, and I'm going to ask for a show of hands in this, how many people would agree there's been too much talk and not enough action in this field? Anybody think that there's too much action and not enough talk? Oh, is that your hand? No, you were okay. Then it's unanimous. And I agree. We have a problem here. We all know that Florida is supposed to be a leader in biofuels and biomass, but with the exception of some progress in timber biomass over the past few years, where we are making headway, there aren't too many successes to talk about. For a moment, I'll talk about one example that's particular to me. Several of us invested in planting a crop called Canaf 2 years ago in South Florida. The crop was taken by a farmer and cut for seed without our knowledge. The remainder of it sits in rolls in a field in a state that really can't be shipped anywhere. The crop for this year still sits in the field unharvested, and when it's all said and told, we have 2 years of harvest, which total less than 2,000 acres total. That's the sum produce of renewable feedstock farming in Florida, sitting in fields without a pellet plant to process it, a decorticator to shred it, or a buyer to buy it. And at this point, it doesn't look like even the Europeans, with their cap-and-trade dollars, have enough money to purchase what it costs to plant and grow this stuff. Camelina, another example. There's about 2,000 acres of camelina planted in Florida. There should be about 100,000 planted in it. Until a few months ago, there was no place in Florida that could take the camelina seed and crush it into an oil where it could be processed into fuel. But even if you could do that, it was only until a couple of months ago that it was even certified for trading as an advanced biofuel, as REN. That's also happening with jatropha. You can grow jatropha like crazy in Florida. It takes time to establish it. But there is no RIN trading at all for jatropha. So we have all these products, all these crops that we could be active in, and we aren't because we don't know what the hurdles are. We don't know what the roadblocks are or the gaps in our knowledge. So what I've asked our panelists here today to do is to focus in their presentations and their responses to your questions about how, as George Bush Sr. once put it so eloquently, how they can help clear the way so the big money can start moving. What are the impediments to biomass and biofuel development in the state? How did they, with their projects or what they're planning to do, overcome them, or how will they overcome them? And at the end of the day, how many of us are in this business to make money? Be honest. Okay, most of us are. And how can we make money profitably, or from the taxpayer side, how do we save money and spend it efficiently with what we're doing here? I'm going to ask each presenter to talk a little bit about themselves, and we'll start the presentations. After each presentation, which I ask be about 10 minutes, we'll take a couple of questions for each presenter. Barring no additional questions, we'll move on to the next presenter. If we have more than 2 questions, we'll hold them to the end. At the end, after all 4 presenters are done, we'll open it up just to general questions. And I apologize, this room is so hot, it's not my doing. Let's start, first of all, with Chris Cook here in the end. Chris with 45th Space Wing.
Hey, how you doing? Good afternoon. My name is Chris Cook. I'm I'm the Resource Efficiency Manager for the 45th Space Wing, so I cover Patrick, Cape Canaveral, and I also go downrange to Antigua and Ascension. I also do some work with Space Command out in Colorado Springs. We're working on a couple of strategic sourcing initiatives and things like that for Space Command, which comprises of about roughly 15 bases. So my interest here is in getting some renewables going, and getting some biomass counts as renewable. So it's all part of the goals of the federal government.
There you go.
That's it.
Pauly Elvington sitting next to me.
My name's Pauly Elvington. I work for Mainstream Engineering, which is a small company in Rockledge, Florida. Traditionally a contract R&D company, although over the last dozen or so years has now become a manufacturing company of power products and energy control or thermal control products as well. So we're involved in biofuels more on the R&D side at this point, in doing some advanced development of a portable pyrolysis reactor system for the conversion of waste biomass into liquid fuels, and that's what I'm here to talk about a little bit. And I'm a chemical engineer by training, and joined Mainstream about 4 years ago, back in 2007. So.
Excellent. Yuri Rodriguez with Brevard County.
My name is Rodriguez Yuri. I work for Brevard County. I'm the director of solid waste. Been there as a director since the year 2000. All the disposal needs for Brevard County, including inside the city, and we're also responsible for the collection in unincorporated areas.
Thank you, Yuri. And sitting here in front, John Urbanchuk.
Hi, I'm John Urbanchuk. I'm a technical director for environmental economics at Cardinal Entrix. We're you'll see in a few minutes, a large environmental consulting firm. My area is biofuel and agriculture. I'll tell you a little bit more about that when we get into it.
Yeah, we even got pictures of us all here, too. John, you're first up.
Okay. Well, see, I promised you'd be more.
I'll let you plug your own button,
Thanks,
too.
Steve.
Yeah.
Appreciate that. That's good. Well, we are, as I said, a professional environmental consulting company. We specialize in water, environmental risk management, natural resource economics is what I do, and a whole lot of different areas. We're a national company, if you will. We've got offices also in South America. We've got a large presence here in Florida. One of my colleagues, Sharon Nemchik, from
West Palm.
Thank you, West Palm. I keep wanting to say, well, anyway, West Palm is here with us. It's closer. And we've got a very large office over. We have 7 offices here in Florida, so we're heavily involved here. We've got about 1,600 people on staff. All ists you can think of: biologists, chemists, geologists, oceanographers. Well, not this, but you know what I mean. And economists as well. So we're heavily involved. And as I said, my area is, where is it? How do we go forward with this?
I just click on the mouse.
Oh, that would probably do it. How about that? Is the area of biofuels. And we're doing work here in Florida. So what I wanted to cover is some of the issues facing Florida biofuels industry. And you'll get a sense of some of the issues we talked about, that Steve talked about, will come to fore here to sort of explain where we are today, why we're where we are today, and where we're likely to go, and what some of the problems for us getting there are. But these issues are policy, demand, meeting the RFS targets, renewable fuel standard targets, part of the energy bill that was passed under the first Bush administration. It's been expanded. It says we've got to get to 36 billion gallons of renewable fuels in the nation's motor supply by 2022. We're not going to get there, but it's a good target to work toward. And then what the implications of this are. And these are important for Florida: water and land use, and of course jobs and economic development. As you know, the U.S. biofuels industry has grown significantly. I've only gone back to 2000. If you take a look back in 2000, we produced less than 2 billion gallons of ethanol. Last year, we produced 14 billion gallons of ethanol. Biodiesel industry is relatively new. Back in 2005, it was about 75 or less than 100 million gallons. Last year, we produced 1.1 billion gallons of biodiesel in the U.S. We had a drop in 2010. We can talk about why. That was policy-oriented. Okay, basically, we lost the tax credit for biodiesel, and people stopped making it, and production fell. It was reinstituted in 2011. Production came back up again, and it's gone again. So it's going to be interesting to see what happens. Florida's participated in this growth. You are the 3rd largest gasoline and ethanol market in the United States. People don't think of Florida in that context. You're the 3rd largest market in terms of gallons used, in terms of drivers, in terms of miles driven, in terms of vehicles. You're a big deal, but you're not in the Corn Belt. And that's been one of the problems. Ethanol demand globally, nationally, if you will, has grown because of the removal of MTBE and gasoline. That was one of the things that was added when lead was taken out to add back octane. Everybody complained about MTBE because it started showing up in wells. The other available alternate oxygenate was ethanol, and that's been used now. We used to say in the ethanol industry is that if you spill MTBE in a well, you've got to cap it. If you spill ethanol in a well, you add ice and have a party. That's not too far from the truth. You got 5 active biodiesel plants here in Florida that are produced about 6 million gallons in 2011, but you're not making any ethanol to speak of in the state of Florida right now. Growth in ethanol is not limited to the U.S. If you take a look at world ethanol production, it's expected to double over the next decade. We're down at the bottom, that blue. U.S. and Brazil account for about 90% of all the ethanol produced in the United States. We make it today out of corn primarily. Brazil makes it out of sugar cane. One of the opportunities for Florida is to make ethanol out of sugar, out of cane, out of energy cane, not necessarily intended for the sugar market. And there are other alternatives as well. The question is, how are you going to participate in this future growth? One of the issues is that we go to that 36 billion gallons, the RFS caps at corn ethanol, or ethanol from cornstarch, at 15 billion gallons by 2015. I told you we produced last year 14.1, a little less than 14.1 billion gallons. We have capacity at 14.8. There's not going to be a lot of additional growth in the corn ethanol business. But we've got 21 billion additional gallons we've got to produce. Actually, it's 20 because a billion of that's going to be biodiesel. Maybe a little bit more if we're successful in working with the EPA, which is what we're doing right now to get that target raised from 1 to 1.3 billion. Okay? All of this growth is going to come from new feedstocks, and Florida has an opportunity there. Federal policy, as I said, is clouded. We lost the federal excise tax credit for ethanol and for biodiesel in 2011. It expired at the end of the year. So now we're going to, the critics are going to get their chance. Are we going to be able to stand on our own 2 feet? I believe we can, and we will. We also lost a tariff. We had a tariff for ethanol that basically was intended to keep U.S. taxpayer dollars from going to a foreign producer. That's out of the way. So what that's doing is that's stimulating investment, but not here in Brazil. And that ethanol is going to come back to the United States. Not next year, and maybe not the year after that, but they've got problems with their sugar crop. But after that recovers, and recover it will, that ethanol is going to come into the U.S. So that means the competitive environment to attract investment funds is going to be intense too, which means that you've got to look to figure out where your competitive advantage is, where your comparative advantage is. And, competitive and comparative advantage work together to create opportunity. How's the industry going to expand? Well, one of the problems we have is that the conversion technology for these new advanced biofuel feedstocks is uncertain. It's unproven. Oh, it works at a laboratory bench scale, but it hasn't been commercially exploited. Yes?
No pilot plants?
There are pilot plants, yeah. But I consider that to be a big bench test, if you will. Well, it is. The average ethanol plant in the United States today is 70 million gallons a year. Okay? New ones are 100 to 110 million.
Isn't enough?
Say again?
5,000 to 10,000 gallons isn't enough?
For an ethanol plant? For a biodiesel plant it is, but not for an ethanol plant.
For pilot plant?
For a pilot plant, you'd probably want a bigger pilot plant than that. But one of the things you've got to do, and this is one of the problems we have with this new technology, is one, the conversion technology is not established. Okay? And here, this is the way you can go. You can go with a chemical, which is an acid hydrolysis process, which has typically been used. We're talking about cellulose here. It's all that green stuff that's out there, the stuff that makes the grass stand up and the trees stand up. Well, there's sucrose in the middle of those things. You've got to break the cell walls down to get to it. I'm not an engineer. I'm not a chemist. I'm not an engineer. From an economist perspective, what I understand, you need basically a number of ways to do that. You can do it by using acid hydrolysis. That's typically been used. It's horribly expensive, and you're dealing with hydrochloric acid and sulfuric acid, and that has all kinds of corollary problems associated with it. You can use biochemical, enzyme fermentation. Problem with that is there are 2 enzyme manufacturers, and all the enzymes haven't been developed yet. And there are intellectual property protection problems, there are pricing problems associated with that. In order for it to be commercially viable, those enzyme prices have to come down from 75 cents a pound to in the area of 5 to 10 cents a pound. They ain't close to that right yet. Okay? Plus the fact that the capital costs are high. You can use a thermochemical gasification or pyrolysis process. We talked about that. We're going to be talking about that with mainstream engineering. They've got a pyrolysis application that works. I haven't seen theirs, but I've seen other pyrolysis. It does work. Problem is that it doesn't produce a lot of material. Okay? And then algae, and we've talked about algae as well. But there are problems with algae too. It's expensive. And you've got to have feed costs that will permit you to produce a biofuel that's competitive with gasoline. And there lies the problem. I'll go quicker. Challenge is going to be the rate of expansion. To produce that 15 billion gallons is no problem. We can produce more than 1 billion gallons of biomass, biodiesel today without building a new plant, but new plants will be built. If you assume a 60 million gallon per capacity, that number's wrong. It's actually 400 plants that you need. Over the next 10 years, 15 years, we can't do that. We don't have the infrastructure to build that. Florida is well positioned to capitalize on the need for these feedstocks, the traditional feedstocks and new feedstocks. I have two in red that work in Florida right now, sweet sorghum and sugar cane. Sugar cane is an approved biofuel feedstock for RIN trading. Sweet sorghum is under review right now, and we expect will be approved for RIN trading as well. And then the new ones, energy grasses, energy crops, everything from pelican grass, switchgrass, you name the grasses, all those grasses that are out there that grow, they can be used and cultivated. They're perennials. Forest residues and woody biomass, municipal solid waste, and then algae. Okay, I'm going to go over this. Anybody who wants a copy of these, I'll be more than happy to send them to you. And we're running through here a little bit, a little late. One of the issues I want to talk about is the fact that building biofuels industry here benefits the economy. We spend a lot of time working with people to help demonstrate if you put a facility in and it's well managed and well run, what are the benefits that it gets? If you take a look at this, operating it creates output, puts money in farmers' pockets, expands local economies. These are permanent impacts. The construction impacts are also there, but they're temporary. Types of impacts, direct, indirect, and induced, you're all familiar with that. Direct is what you get from doing it. The indirect is the secondary. And then third is that every dollar circulates throughout the economy. We are working with a group out in Highlands County, Highlands Envirofuels, that is in the final stages of finalizing a 30 million gallon a year ethanol plant that's going to use energy cane and sweet sorghum. And they asked us to estimate what the economic impact of that will be for Highlands County. To give you an idea, they're going to produce ethanol, and they're going to produce a byproduct of syrup feed that will go to the cattle industry, and they will take the excess electricity that they're going to generate, because they're going to be burning the gas from the sugar cane to generate their electricity. So their production costs are going to be lower than conventional ethanol, because they're not going to use natural gas. They're going to be selling electricity back to the grid. And of course, building it is going to provide an impact. So when you take a look at this, the total impact, direct, indirect, and induced, in construction is about $47 million, operations 51. They're going to add up almost $100 million to the local economy, and that's just within Highlands County. In terms of output, and that's final demand. If you look at it in terms of GDP. From the income side, this is household income. It's going to add about $83 million to household income for the residents of that county. I don't know if you know Highlands County, but it's a rural agricultural county. And this is sorely needed for them. And that is going to support jobs. It's going to create directly about 1,100 jobs, 60 in the production side and the manufacturing and the construction side, about 1,000. It'll support 2,100 jobs for the local community, and that's an important consideration. So in conclusion, what I want you to take away from this is production is going to continue to expand, but there are significant challenges. We're near the ceiling for corn ethanol, and we need these new technologies. And you guys are well positioned from a land base, from an agronomic perspective, to produce those, but it's going to require investment. It's going to challenge resources, but farmers and all Floridians are going to benefit from that. With that, I think I've just about run out of time. I'll be happy to answer any questions. Anybody who wants a copy of this, let me know. Give me a business card or your email address, and I'll send it out to you. With that,
Sure, John, somebody's got some questions. Thank you very much.
I apologize for going quickly, but we were going to get through this stuff quickly. Any questions? Nobody fell off their chair, so I was okay there. Yeah, go ahead. Yes.
Is the limit for the production from corn, is that a regulation or is that
Yes.
a land mass?
You know, that's a limitation. Under the Renewable Fuel Standard, which basically prescribes how much renewable biomass fuel is going to be used, it limits the amount of ethanol from cornstarch at 15 billion gallons. That is the only you can produce more than that, but you can't use it for purposes of program compliance. And the reason for that is you're all familiar with the fact that people are concerned over the fact that if you use corn to make ethanol, then it screws up food prices. That's a BS argument, and I'd be happy to explain why that's not the case and the fact that it's overstated and overblown. But we don't have time to do that right now, so get me afterwards. I'll be happy. That is a bogus argument. Okay. The point of the matter is that that's one of the reasons that it's capped at 15 billion. So we have really an interesting paradox here. We have legislation, it's actually legislation, it's a law that says we have to get to 36 billion, which means that the EPA can't say you can't do it. They've got to go in and have the law changed. All right? But they put constraints on how you get there. Moreover, right now we use 10% ethanol. The EPA has said, okay, for automobiles manufactured after 2001, you can use 15% ethanol. And of course, there's the issue with small engines and marine engines and that sort of thing that's constraining that. So they're going to say you're going to use 15 billion. You have to use 15 billion, or you can make 15 billion, but you can only use 10%, which is roughly about 10 billion. It's screwed. It's sort of like this situation where last year, the EPA, one part of the EPA said you've got to use cellulosic biofuels. And if you don't, you'll be fined. And the other part of the EPA said, well, you didn't use any cellulosic biofuels, so you're being fined. And the guys who were being fined said, nobody's making this up, we can't buy it. Oh, so you still have to pay the fine.
If you had to, I'll throw one, then I'll take one more. John, if you had to identify one roadblock in Florida toward plant development, let's take that in first here, plant development, what would you see it as?
I think the biggest significant issue is capital availability more than anything else. There are a lot of people with a lot of good ideas, okay, to develop crops. It's a chicken and egg situation. One, you've got to develop the feedstocks. You're not going to put a plant if you don't have the feedstocks. So you've got to have a plan to produce the feedstocks necessary to supply a plant, which means that people have to change around economic practices, they have to change crops, and that requires investment capital. And then somebody's got to build the plant, and that requires investment capital. And getting the attention of lenders, whether they're private equity firms or commercial lenders, is a real challenge. I was in a group of economists, just another 30 seconds, a group of economists get together a couple times a year in Washington, and this year we met last week, and we had an opportunity to sit down with Chairman Bernanke and the other governors of the Reserve Board, and we're sitting around talking about issues such as capital availability. He said, well, we've given money to the banks, the money is there, but we're having a hard time getting to actually lend. And what's happened is that because they all screwed up in the housing industry, and I think you guys have heard about that here in Florida, all the banks have tightened their lending restrictions so tight that it's virtually impossible for new borrowers to come out and comply with those strict lending requirements because the banks are not willing to undertake any kind of risk. So that's, I think, one of the key problems right now. You need financing at both ends, one for feedstock development and two for plant construction. Now, I wish I had an answer for that. I don't.
That's great. John, thank you very much. Please. Remember at the end, I think this is the, Mike, this is the last one this afternoon, isn't it?
There is a finance panel actually after this.
Oh, primary, so we do have to...
Straight on to that.
Okay, there you go. Oh, this was his last
That's, by
slide.
the way, is the only thing I agree with him on.
Next up, Yuri, Brevard County Solid Waste Management. It's all yours, sir. And we're going to be talking about, well, we know that Brevard's engaged in a lot of interesting projects here, and it's all yours.
Thank you. Well, sure.
Mission statement pretty much environmentally sound, efficient solid waste, protect the customers out there. Pretty much Brevard County has what you would call a monopoly on the garbage in Brevard County. In 1967, the state legislature gave it to them, or to us. The cities at that time gave up their right to run any landfills, and from that point on, the board has done it to the Solid Waste Management Department. Be able to get bonds and grant franchises for it. The franchises, pretty much the only thing that we use them for is on the collection side. What we are is what's known as an integrated solid waste system. We have disposal, transportation. We have transfer stations, mulching facilities, household hazardous waste, and current recycling rate. Year 2009, and I apologize for that, but the state is very slow on certifying those numbers. It's 35%. I'm not going to go over the numbers, but you can see them there for yourself. And numbers have come down dramatically. He talked to me about during the peak time before the bubble, and it was probably at least, I'd say about 40% higher than what those numbers refer to right now. Class 1, which is regular garbage, pick it up on the streets. The haulers pick it up from commercials and residentials, take it either to a transfer station, which then goes to the landfill, or it's direct haul to the landfill. And this is an aerial of our landfill over in Cocoa, just on the other side of 95, north is that way. That's 95 up there on the top. You can see that this part over here is what we call our old slurry wall landfill. For purposes, it's the active portion of the landfill right now. Right now, all this over here is our future expansion area. That old landfill has probably about 6 more years of life on it. Don't quote me on that. Every time the engineers give me a life, they're wrong. So what we got to do is we're going to get ready for expansion of first cell here. We'll be developing and being able to take care of that issue in the future. See here, this was our yard waste facility, and we were just making preparations, building another one over here in order to move it around. Sarno Road. Sarno Road landfill takes class 3 material, construction and demolition, yard waste. We also have tires in there, metal piles, but mainly construction and demolition. That's the active part of the landfill is right here. We're doing an expansion area over here. Don't pay attention to that. That's a private facility. A transfer station, a household hazardous waste facility. And at Sarno Road landfill over here is Wickham Road. It's smack in the middle. The city doesn't want us there, so we're permitting right now 3,000 acres off of 192, right on the borderline with Osceola County. We've obtained our first permit over there. It's a long, drawn-out process, and I expect the permitting process to go on for several years. Those 3,000 acres, we're going to start with a construction and demolition landfill out there, and pretty much we've got something that's called an expansion area out there, but in reality that's probably going to be future technology out there. And what we've been doing lately as far as using the existing technology is we have a landfill gas to energy. It's a partnership with Landfill Energy Systems. They pay us a portion. We give them all the gas. They got a monopoly on the gas. A picture of the gas well goes over here, and they burn it. They got 6 engines over there, and it's producing. We'll get to the next slide again, but it's producing about a 9-point-something megawatt plant, and that's all its equivalent. From our perspective, this is the important thing. We were pretty much in the past burning it up, flaring it up, no beneficial use. This year, because of tax credits and the sale of it, we are expecting to receive $650,000 worth of our share. Biodiesel fuel. Several years ago, we started looking at it, and pretty much what caught my attention, to be quite honest with you, is it was 5 cents cheaper than regular diesel. So we started looking at it and did some experimentation. The first one that we bought, and we're using it for all our fleet that uses diesel. We do not make a distinction between them. We use 20% during the summer, and we bring it down to 5% during the winter. That was in basis of a bad experience that we had when we first bought it. It gelled up during the winter time, and we were not able to use it. We had to pump it out, bring regular diesel in, and dilute it until we could get it to about 5%. And we've been keeping it at 5% right now. I think it was palm oil that it was mixed in with. We buy it from Glover. Glover has told us that they are using other additives right now. I got several samples on in my office right now, and they're about to go from the windsill over to the refrigerator and then to the freezer. Not very scientific about it, but if it gels in the freezer, we don't want it. Like I said, about 5 cents per gallon, and believe it or not, we buy 500,000 gallons a year of fuel, pretty much constant, all the time. And we've been able to save with that 5 cents, $25,000 a year. Currently, right now, we had advertised for a request for proposal. Several firms responded to that. We are looking at a way of taking any technology out there and tucking it into our operations, be it as a complete replacement of the operations or as a supplement to our operations. The key to the whole thing is provide us cheap, and we do not want our rates to go up. Okay, so that's going to be one of the key things in it. The first meeting, we already got the package, so the first meeting of the committee is going to be this week. But we've got several of them for gasification, biofuel, incineration, converting it to fuel pellets and other technologies. So we'll be reviewing that. Another thing that we're looking at is equipment out there. What kind of equipment will bring my fuel costs down? This is a new D7E that Caterpillar has put out. Actually, it's a picture of it in our landfill. We field tested it for a while. During the field test, it used about 3 gallons less per hour, and that's a lot. Because I was using probably about 9 point something, almost 10 gallons an hour on that diesel, and now this one's going to be using around 7. Because the engine is running in order then to take it to, I don't know, whatever the generation of electricity, and then the electrical thing is the one that gears or runs the whole machine. It uses 30% oil, and according to Caterpillar, the maintenance on it is estimated to be 25% less. We have currently ordered our first one. Pretty much, we are looking long range to keep our costs down and enhance our revenues. And I brought this up because it's the first thing that occurred to me. These landfills are going to be closed, and as they become closed, they, instead of being an asset-producing capital asset, then they become a liability. You got to take care of them for the next 30 years. You got to cut the grass, you got to do a bunch of other stuff anyway, and 30 years if you're lucky. I've been reading and doing some research and all that, and I'm not an expert by any means, but what caught my attention was that there's some new technology out there that they're using solar panels on some of the sides of these landfills. Solar panels, especially considering in Cocoa, which already has a connection to the grid, May or may not be cost effective. I don't know, but it's a possibility that we would like to explore sometime in the future. That's it for me.
Questions for Yuri? That's right over here.
Are those numbers that you gave on that new equipment, is that with the diesel, regular diesel, or biodiesel? The 30% less oil per gallon less diesel?
That's biodiesel. We haven't used regular diesel in the last 2 years, and that experiment that we did was probably about 2 months ago. That's biodiesel.
That was
And that was 20%.
That was B20.
You, sir, had a question.
Waste management, is that part of the national chain of waste management companies, or you just do?
We're solid waste management. The company Waste Management Incorporated is part of the chain, yes, and they have a contract with us to do collection.
Okay, well then the question I have leads probably to the bigger corporation, is that are they looking at ways to, instead of just burying this type of material, maybe through technologies like you have for the pyrolysis and things like that, so that we don't need landfills, we actually convert it to natural gas and oil and things like that. Are they seriously looking at things like that?
Yes, they are. They bought companies that do composting recently. They have partnership, or they bought into one of these big incineration companies. They are currently expanding their portfolio of just pure landfills. But I will tell you, one of the biggest impediments to this is cost. An incineration plant. Palm Beach County recently went through the process of getting an incineration plant. Can't remember the tonnage per day, but it cost them around $300 million. That's a lot of money. And you're talking about also that Palm Beach County charges at a minimum $60 a ton. Brevard County charges $29.50 a ton. It's the cheapest one around. Why? Because all our capital investments were made way in the past. It might be different in the future, but we still got expansion area. But I can't think in terms of they don't pay me to think in terms of 5 years. I got to think in terms of 20 years, what's going to happen in 20 years. And where am I going, and do I have enough capacity to take care of the garbage needs for Brevard County? And that includes yard waste, garbage, metals, construction and demolition. All of that pretty much ends in our landfill except for the construction and demolition, where it's the only place where we have competition.
John, can I ask that you hold yours, because we are running pretty late here, but that's great. Yuri, thank you very much. How many people here live in Brevard? And how many would agree that solid waste collection in this county is the freaking best in the state of Florida? Yeah, okay, so thank you. I appreciate that. Next up, Pauly Elvington, Senior Chemical Engineer, so I suppose we all have to get our slide rules and get ready for it.
Right. I'll ask you to memorize the periodic table before the end of this. No, but I am a technologist, so I'll be talking more about the technology side. And, you know, as John mentioned, there are some big challenges on the technology side. I think that's one of the big barriers to making, biofuels a reality, is that it's not easy, especially when you're starting from agricultural residues or MSW and that sort of thing, instead of devoted energy crops. It gets even more challenging. So that's where I've been working. So this is just a little bit about the company. So biofuels is part of our business, but more broadly, it's an energy conversion and thermal control company. So we develop engines, we develop turbo machinery, we develop high heat flux cooling applications for the military. So what I'm going to talk about today is pyrolysis. So it's different than fermentation, for example, to make ethanol. So we're not talking about making ethanol. We're talking about making a bio oil that's in some ways similar to a petroleum-derived oil, although it's not the same. There's some important differences with that. But this is kind of our vision for biofuel in the state of Florida, and I think this is part of the solution. I don't think there's a silver bullet as far as particular technology conversion platform to produce biofuels. But our vision is to have portable reactor units that are positioned at the source of the biofuel production. So one of the big problems with biomass and biofuels is that you really can't make money if you have to ship the feedstock more than about 50 or 75 miles. So if you have these big fixed sites, then you have a limited radius that you can collect from and still make money. So our approach is to take the conversion process to the farm or to the landfill and process it on site. And so we're working towards developing these 10-ton per day containerized reactor systems that fit in standard intermodal shipping container, and use pyrolysis, which is a thermochemical process. So it's got some nice advantages. We like to say it's kind of omnivorous, so you don't have to give it, for example, one particular feedstock, but you can give it paper, you can give it certain plastics, ag residues like sugarcane bagasse, and orange bulb and logging residues, and it's fairly universal. Doesn't require any kind of expensive consumables like some of the things John mentioned for the pre-treatment, acids or enzymes, that sort of thing. And produces a bio oil, which can be upgraded into a renewable fuel oil. It's the initial market that we're targeting. So a replacement for a number 6 fuel oil, which is used to, in electric power generation in Florida, about 10% of our power comes from oil-fired power plants. And it's also used as a marine fuel for large marine diesels. So the stage we're at right now is the pilot stage. This is a 1-ton per day pilot plant. The scale on this skidded reactor system is about 8 feet by 8 feet by 8 feet, to give you an idea of the scale. So this is 1/10 of the full scale as we see it. And you had asked a question about how big is big enough as far as pilot plants. And DOE's rule of thumb is that if it works at 1/10 scale, you can be reasonably sure that it will work at full scale. So that's why we decided to go with this scale. So it's an exciting time for us. We actually just finished this unit within the last 2 weeks, and we're in the process of commissioning it and doing some shakedown testing, and then doing some testing with different feedstocks, initially looking at the ag residues, sugarcane bagasse, logging residue, orange pulp, and then down the road looking at some other things like the organic constituents of MSW and yard waste, for example. MSW is a little bit harder, obviously, because you have the inorganic material in there, so you have a little more to worry about on the pre-processing side. So we're focusing on the ag residues as kind of the low-hanging fruit initially. And we think we can make money doing this, so we've done some economic modeling, and we're estimating that the CapEx for one of these 10-ton per day units will be about $1.25 million, so a little over $1 million, which is considerably less than a big fixed biofuels conversion plant, like a big ethanol plant, for example, which could run hundreds of millions of dollars. So the risks are lower, and that's a good thing in terms of trying to get some experience with this out in the field. In terms of CapEx, it works out to be about $3.70 per annual gallon of capacity, which is very competitive with other advanced biofuel processes that can process lignocellulosic type material. And in terms of the operating cost, that works out to be about $1.85 per gallon of number 6 equivalent if you make sure that everything is apples to apples in terms of the energy value of our fuel compared to the energy value of number 6. And that compares to current prices for low sulfur number 6, so about $2.88. So we think we've got a pretty healthy margin in terms of the breakdown of cost. Upgrading feedstocks and operators and depreciation make up well over 3/4 of our total cost. So that kind of tells you where the money's going. So One last slide. I try to keep this short, but just some of the challenges and next steps. So we think there's a good upside to thermochemical conversion and pyrolysis, but there are challenges like there are with all the platforms. And some of ours are demonstrating reliability, determining the properties of the oil with different feedstocks like logging residue, sugarcane, field trash, demonstrating the upgrading process to get the oil to the point where it can be a drop-in replacement for number 6. And then doing some demonstrations of kind of the end use of the oil in an industrial burner boiler, burner furnace, for example. So, yeah, that's all that. Thanks.
Okay, so that was a 1 ton a day unit.
Right,
8
yeah.
by 8 by 8, and you're expecting the 10 ton will scale up to a standard Connex container? Is that what you guys are anticipating?
Right, yeah, 53-foot, standard intermodal container, right.
Extra long.
Well, yeah, it's a standard length thing. So, yeah, obviously it doesn't scale linearly.
Right.
Yeah.
Yes, sir.
Wondering, yeah.
I was working on a remediation program in Ukraine. You recall Chernobyl?
I've heard of it.
Heard of it. We were using Solanthus species to pull heavy metal out of the soil. That's sunflowers. Worked very well, but getting rid of the biomass was a real problem. The problem there, of course, was there were heavy metals in the material. I did that with this.
Because you process, radioactive sunflower.
It's radioactive. It's heavy metals.
Yeah.
The issues, transuranics, so cadmium and vigor.
Yeah, it's a good question. I mean, I didn't mention it, but one of the co-products that we produce is a char, a biochar, that actually has potential markets as a soil amendment. But yeah, I think all your heavy metals would most likely end up in biochar. So.
Yeah, the problem with the char would be the carbon in it, because the next step was to place the material in large glass pools, about a yard in diameter, to be several yards long. We figured that Ahmed couldn't load that in his pickup truck. Create problems with it. It was in a huge glass pool. But you can't do that with carbon because of the cracked glass. But that would be a process that you have to have later. This looks like a good way to do this. A really good way to do this if we ever have a remediation disaster.
Sometimes you get what you wish for. Let's hope not.
Right. If it's ready, let's use it.
Yeah,
You go ahead and answer that way. We've got to move on and get the last presentation.
Yeah, another interesting application that we've talked to some folks in South Florida about is processing debris after storms. So yeah, there's some other interesting applications for disaster. Yeah.
That's cool.
But aren't you limited by what your feedstock is on that? It seems like right now you've got sort of limited feedstocks. You have to deal within their parameters rather than the municipal solid waste you mentioned is what
Are we limited by the availability of the feedstock?
Well, the availability is location.
Consistency.
Yeah, that's one of the nice things about the process compared to fermentation is that, like I mentioned, it's fairly omnivorous, and we've tried a lot of different feedstocks, and the pyrolysis kinetics are amazingly similar. So it's pretty universal, and that's what you get with a thermochemical process, especially ours. So that's a good thing, and there is plenty of waste biomass in the state. If you used all of it, there is approaching 1 billion gallons a year of capacity.
I just want to make sure.
Okay.
Can I ask you to hold that one? Because we're at 4 and we're supposed to be moving,
sure.
but hang on to that question. I'd like to introduce our final speaker, and I've always wanted to ask this question of you. Where are the other 44 space wings? If you're the 40th.
It's kind of like the 8th Air Force.
Yeah, okay. Anyway, we have Chris Cook from the 45th Space Wing, final presenter today.
Actually,
Here we go.
I'm not. I didn't put together a presentation. I figured that way I'd be forced to actually read something and do it. So I'm going to kind of wing it here and let you know what's going on. I'm really not with the 45th Space Wing. I have my own consulting firm. It's called AeroPro, and I am being contracted to the 45th Space Wing to perform a resource efficiency management services. I've been in the area for a long, long time, worked on the shuttle program, payloads. Then I got into the facility energy world. I was a energy manager, renewable alternative fuels manager at Kennedy Space Center for a contractor for a while. I'm a board member at the Merritt Island Redevelopment Agency, put a plug in for them there too. So we're looking, I'm kind of in between all these guys. I'm an engineer by trade. I do a lot of work with the government, and I develop projects kind of like John to put things together. So I cover everything. I do lighting, HVAC, whatever I can do to save a buck. But why am I looking at renewables? Is because a lot of reasons. The DoD is the number one user. The federal government is the number one user of energy in this country. We all know that. Right now, per EPAC, we're supposed to be at 7.5% of all our electric production is supposed to be renewable. I think as a country, we're at about 8%? You guys might know more than that here. But the space wing here, we're even using all the big wind turbines we have down on Ascension Island, we're still at way under 1%. So we're way behind the curve. I keep on getting asked to develop renewable energy projects. The trouble is I go and I develop them, I put them all together, they look nice, and they can go up for funding, and they look at them and go, nah, it doesn't meet anywhere near our economic requirements that we need. So if you guys can help me out and put together a project, I can get somewhere even close to a good return on investment and give me an SIR of near 1, we can get it funded and get it installed. Well, we've had some. The other challenges we have being on a DoD base is security. We can't have a bunch of trucks coming into the base. We can't put up big wind turbines because radars and things like that nature. We're also in the middle of a wildlife refuge, and the sea turtle people get all upset. And they were out there late today looking for mice on the beach. I saw them out there. I'm like, okay. I love the environmentalists. I'm a huge outdoorsman, but the number one impediment I have to implementing renewable energy projects is environmentalists. They're their own worst enemy so many times. It's kind of frustrating. The other thing that's frustrating, I believe, with John is the Air Force itself is they don't like to be on the bleeding edge of technology. They like to be on the leading edge, and sometimes they get very, very conservative. I got a project now to install LED lights all over the whole base. That's a lot of lights, and actually it's through command, so it's on 10 bases. We're looking at something like 16,000 units at over $450 a unit. But anyways, you can do the math on what the size of that project is. But what was I going to say? I got distracted. But anyways, they're their own problem. So we're looking at, one of the things we're looking at is that's in the favor of renewables is energy security. There's a big push now with all the terrorists and everything that they want to have the base. What happens if the FPL lines get cut? We got 2 lines going on to each base, Cape and Patrick. We just have to have all kinds of plans in place. We got on-site generation capability, but then they tell us we're not allowed to use natural gas to fuel generators, so we have to use fuel oil, which means there's going to be a huge market for fuel oil. If you use the biofuel oil, we have a nice market there on the internet, and we use energy security as a blanket for that, for our reserve generators. Last year we had commissioned a huge study. A big environmental firm came out and said, what can we do here for renewables and biomass? And they came out and we just looked around. They took one look at Patrick and said, not here. There's not enough room. You need about 6 acres, 5 acres, 6 acre space, and they just don't have it there. Between the airfield restrictions and the housing and the beach and the river and the manatees and the sea turtle people, they said no. So we moved it up to Cape. I said, okay, we'll look at the Cape. We got thousands and thousands of acres of place up there. But it gets awful small really quick when you get rid of all along the wetlands, you get rid of the secure areas, you get rid of the beach, and when you look at a radius, usually they say, like you said, a 50-mile radius for your fuel stock, half of that 50-mile radius is in the ocean, so your land for your feedstock gets even smaller. But they said that we do have, the final results of that study said that we do have enough land area for some biomass, particularly, but the on-base, all they really have is Brazilian peppers and some switchgrass. And going in and trying to get security to go in and cut it and dealing with launch schedules and hazardous operations and secure operations, they said, no, it's not going to cut it. So that we went, okay, plan B, let's look at municipal solid waste. So I went out and had a long conversation with my friend Yuri, and Yuri says, hey, bring it. Well, let's get together and get a plant together. Let's have some discussions. So we did that, and we're looking at it, and unfortunately, due to the energy security aspect of the contract, they couldn't look at using the existing landfill site. So they picked out 3 or 4 sites on the base. Same thing. The only place that made sense was right at the gate. So you couldn't bring the trucks in, and of course that route put it right next to all the cruise boats and cruise terminals there. And the port people weren't real happy about bringing in a truck every 6 minutes or something like that through, and the commander wasn't real happy about having a plant right at his front gate of his base. So it screams out. It just makes common sense. The economics are there. We're looking at about a 14 megawatt plant for just the MSW generated by Patrick in the Cape. And we had enough feedstock for that. That's what the study came out.
And when you said feedstock, you're talking about the solid
Trash.
waste stream from all the municipalities and
No, just from Patrick Air Force Base and Cape Canaveral Air Force Station. Okay, so there's a lot of trash, and just because we wouldn't interfere with any of the existing transit sites. It just makes so much sense. His infrastructure is up there. He's got the transmission lines. He's got everything there to go. And I don't know if you guys drive over on 528, look over, you can see the hill now. Before you couldn't. But now you can look over and see it. It's getting that he's going to have to expand, and it's a lot of money. When you factor that cost into the project economics, it makes it very, very nice project to develop. So the only other issue we're having trouble with is with utilities. Utilities are not really all on board on this, as you would think they would be. They like their own meter to spin. They don't like to see the meter spinning backward. But I think that's minimal. I think we can overcome that. That's the smallest of our issues. So we don't have problems. We just have issues that we overcome. But that's where we're at right now. I mean, the bases, we're open to anything you guys can come up with that can make any kind of economic sense. It's a win-win-win. It really is, and there's a way to do it. It's really frustrating for me because I'm like y'all. I want to see this area grow and prosper. And it's just a shame that all our great energy resources. It's just kind of funny that they're all in the middle where there's not any people. We got the deserts out there with all that solar. We got the Midwest with all the wind, and it's just not where the people is. And the biomass is out in the middle of nowhere too. So, we can overcome it.
Wow. That's questions for Chris.
Yeah, I had one real quick one.
Yes.
You had said to bring me a project and we can get it funded. What is the source of the funding? Federal government?
Yes.
Okay.
DOD or ERPA or what?
DOD. Right now, we're submitting funds. I'm putting together a whole program for FY13, FY14 right now. Usually we put in for FY14, then we'll get funds for design. That way we would implement that. And we could also utilize, we just got a mandate too, that the President wants to have $2 billion in performance contracts, federal performance contracts we have to have a plan together by August on how to spend $2 billion. But it makes sense because the utilities will finance it and we'll just pay it back at these historically low interest rates.
If I can ask just a follow-on to that one, are these all one-off contracts, though, like standard military contracts? It's a competitive bid, it's for 1 year, and then you're in and out? Or
it
are
depends.
these longer term?
If there's a lot of different contract vehicles you can use. You can get with someone who's got a GSA schedule. If you're an 8A company, you can do an unsolicited proposal. You could, or you could go and do a competitive bid, yeah.
I think there's a question over here. Yes, sir.
Yes.
So you use the word "we" a lot, and at the very beginning you told us you're a consultant to do this. So what is "we"?
We is the federal government.
But as far as the energy efficiency and the management, your role at, say, Patrick is what? You talk to Cotton on a daily basis, and Cotton says this is a great idea.
I talked to Cotton on Monday. He wasn't happy.
Okay.
But,
no, I mean, so that's what I'm saying. What's "we" mean?
General, we call him General Cotton.
Yeah, okay.
But my job there is to assist. Actually, let me back up a little bit. My job is actually to assist the Air Force Civil Engineering, FCC.
Okay.
That's who my direct contract is with. They have assigned me to the 45th Space Wing. okay, to help them develop projects to reduce their energy and fossil fuel consumption, meet all the requirements of the EPACT and ESA 07, all that kind of stuff. Okay. So my number one job is to develop projects.
Okay, so we could go after ESTCP money right now.
Yes, sir.
We have a project.
I won on Cape right now, and Tony, we did one with Tony that didn't get funded. So yeah, ESTCP, yeah, absolutely. It's a long and tedious and painful process. It's a long, tedious, and painful process, I assure you, but we do it.
Wow. Thank you. I don't care if it's 10 after. I'm going to take a couple minutes for any follow-up questions that folks have. Chuck, I know that you had one for
Yeah, what do you do with your landfill gas?
It runs 6 turbines, gets sold, gets put on the grid.
Okay, good.
Sold back to FPL? Or progress?
There's a co-op, I think there's a co-op out there that buys it through FPL.
Got it. And I know there was
Connected with FPL.
I know there was another question earlier for Paul. Yeah.
Okay.
Oh, okay, sure. Go ahead, Art.
Do you competitively bid biodiesel purchases, or are you under a long-term contract with Clover, or is that something?
Just competitively, what the county does is they piggyback on the school board contract. School board competitively.
How often?
Any other questions? Yeah.
For Paul, you said that unit that comes out as number 6,
Right.
or is that coming out as something less than number 6 that has to be further refined?
Yeah, so it comes out as what's called bio oil or pyrolysis oil, and it's similar to number 6, but you have to do a little bit of upgrading to get it to number 6.
Burn it straight as number 6 when it comes out. You got to treat it again. Correct?
Right, yeah, there's some options. If you wanted to burn it directly, you'd have to do a few modifications to your burner, because it is more acidic than number 6 fuel. So, without the modifications or without some upgrading, there you'd have some corrosion issues in a standard burner boiler.
Can that be done in reverse? Can it be done to process the fuel so that it doesn't require capital changes to the existing installed equipment that uses number 6, or does it have to be made consumption location?
No, it can be done after, and one kind of attractive idea is to do it centrally. So have these distributed reactors, and then tanker the fuel to a central upgrading facility, and take advantage of some economies of scale. Once you overcome the transportation logistics issue of moving the biomass, the raw biomass. Yeah.
What's the cost of the capital change improvement to make it viable to utilize the bio?
For a burner, for example?
Take a maritime vessel or burner, whatever.
A burner is pretty minimal. There's just a few changes. This has been demonstrated, for example, over in Scandinavia on a fairly large scale. So there's a few components that you've got to replace with stainless, which does pretty good with bio-oil. For a diesel engine, it's a more complicated system. You have moving components. There's some more extensive changes that you have to do. But people have demonstrated that as well, but they haven't really done durability studies to show that it works for thousands of hours. Yeah.
The cost that you showed up there were $1.85 or something like $1.88. Did that include the post?
It does, yeah. It includes that upgrading cost, and that was one of the biggest chunks. Yeah. Mm-hmm.
I actually had one posing question on feedstock. In what form does the feedstock have to arrive for you guys to put it into your reactor?
So there's some pre-processing that goes on, from collection to feeding into the reactor. So what you really need to do is you need to mill it down to a few millimeter particle size, and it has to be dry to about 15% moisture. But there's actually plenty of waste heat in the process to do most of the drying, but you have to do the mechanical size reduction.
So it's actually a solid that you feed into it.
It's a solid, yeah. Mm-hmm. Right.
Actually, Hardin, I was just going to give you a plug. First, this is Hart Bethia. He's with the Florida Opportunity Fund over in Orlando. It's the legislature legislated a chunk of funds for these kinds of projects, and Harton is one of the administrators of that fund. Folks, yeah, okay. Well, we'll be over there in a second too. Thank you, but I want to also, John Leeds from the Energy Office, I know, is floating around here someplace today too. So even though session's going on up there, a few of us escaped to come down for this. I want to thank all of our presenters. There's a lot of interesting information here. I would love to see Yuri. I would love to see the RFP that you put out to see what it was and what you were looking for future reference.
Your email address.
You got it. You haven't done an RFP yet. RFI, yeah, information. It's great. And I want to thank all of you, and I'm sure these guys will be around for more questions, and I'll gab to you about anything you ever want to talk to. So thank you for coming.